We create the access into the pulp chamber with a number 4 high-speed surgical length round burr. I use it in a pecking motion, creating a more or less triangular opening that mirrors the positioning of the mesiobuccal, distal buccal, and palatal canals. This procedure can take several minutes. The precise amount of pulp chamber opening is partially determined by the removal of the undercuts that represents the volume of the pulp chamber after removal of the pulp chamber's roof. Notice how the access is refined by determining where the boundaries of the pulpal floor extend to for easy removal of the pulp tissue. After adequate removal of the overlying tooth structure, I use my explorer to determine the precise location of the canal orifices, removing more overlying tooth structure when necessary for straight line access into the canal orifices. I decided to probe the depth and length of the canals using a 10 safe-sider to see how easily it negotiated to the apex, something it did with little resistance in all 3 canals. I use a light manual watch-winding motion with a small amount of apical pressure to negotiate the length and thereby establishing an accurate length for each canal. Placing a slight curve on the length of the instrument will, at times, improve its apical negotiation. After establishing the patency of the canals to the apex with the 10 safe-sider, I placed a 15 safe-sider into the 30-degree oscillating handpiece and rapidly negotiated to the apex, working the instruments vigorously in the buccolingual plane in the mesiobuccal and distal buccal canals and mesiodistally in the palatal canal. Note the apical control we have when using the safe-siders in the handpiece oscillating at 3,000 to 4,000 cycles per minute. They only advance when apical pressure is applied. After shaping to a 15 safe-sider, I jump sizes to a 25 safe-sider, also using the 30-degree oscillating handpiece. Note how the larger safe-siders follow the glide path established by the thinner, more flexible safe-siders that were first used. As the more instruments become thicker and somewhat less flexible, they have a more and more refined pathway that allows the larger safe-siders to accurately follow. Also note how the larger instruments can more aggressively work the more coronal aspects of the canals, removing any pulp tissue that may be present in oval-shaped canals. After irrigating the debris from the canals, I follow the 25 safe-sider with a 35 safe-sider. Note the milky nature of the irrigant, demonstrating the ability of the safe-siders to shave away small amounts of dentin as well as debriding the canal space of pulp tissue. After shaping the canal to a 35 safe-sider, I started fitting in medium gutta-percha points that had to be cut back in length to fit accurately at the apex with tug-back. After fitting the points, I dried the canals and placed easy-fill epoxy resin cement into each canal using the bidirectional spiral as the applicator. It is used 3 millimeters short of length and applies the cement to the canal walls using several up and down motions of about 10 millimeters amplitude for each canal. The applicator applies the cement without driving the sealer over the apex. I then coat each gutta-percha point liberally with sealer and place it into the canals. At this point, a small amount of cement may extrude apically when no ligament is present to prevent it. The cement is formulated that within 3 weeks after it is placed, the macrophage digests the cement extruded over the apex without any negative consequences. The mesiodistal and buccolingual periapical x-rays show a 3-dimensional fill that really only required 3 instruments for completion. The safe side is 15, 25, and 35. The 10 was initially used, but we could have just as easily started with a 15.